Hello learners, and welcome to a classic physics problem of will it clear the wall. So here we've got an initial velocity of a projectile at 20 meters per second, launched at an angle of 60 degrees from a wall that is 10 meters away and 10 meters tall. Now this is not to scale at all, but you get the idea. And the goal is to figure out if somewhere along the path this ball clears this wall. And so we know how far away the wall is, and we know how tall the wall is, initial velocity, angle. So here's our strategy for this. We're going to need to know the Vx. Well, to get Vx, think about the triangle here. Here's Vx, and then here is Vy. Well, I know the angle. Vx is the adjacent to that angle, so I would do V0 cosine of my angle. To get V0 y, I would do V0 sine of my angle. Because again, so ka toa, being the adjacent, o being the opposite. Now, I know that this wall is 10 meters away, so I know the delta x. Now I could also calculate the Vx, which means that I know two things in an equation, and I could solve for the time it would take for this projectile to get to this plane right here. Now I don't know where in the plane, but I know to get to this spot somewhere along there. So cosine of 60 is going to be 1/2, which means that my Vx is 10 meters per second. Which, by the way, at the apex, or the very top, that's how fast the ball is moving, at 10 meters per second. Because at the top, my y velocity is 0. But that's just an aside. So my delta x is 10. My Vx is 10, which means my time is 1 second to reach this wall here. Okay, well, does it clear the wall, though? That's what we want to know. Does it make it over the wall? Well, we know how much time it takes to get here. So let's figure out where the ball is in this spot. In other words, what is its delta y? Well, delta y equals V0 y t plus 1/2 ay t squared. Now, the time that I'm going to plug in is the time it takes to get to this 10 meter mark. Not here, but the time it takes to get horizontal, 10 meters. So I plug in my values. V0 y is going to be 20 sine of 60, which sine of 60 is square root 3 over 2. So V0 y is 20 times square root 3 over 2, or 10 square roots of 3. So let's plug in all of our values. I've got delta y equals V0 y 10 square root 3 times my time, which is just 1 second. Well, there's just 10 square roots of 3. Now, my ay, I'm just going to use negative 10. And so my ay, that would be minus 1/2 of 10, which would be 5, and then 1 squared, which is just 1. So it's just 10 square roots of 3 minus 5. Well, square root of 3 is like 1.7 something. It's like 1.73. So this is like 17.3 minus 5 meters, which gives me 12.3 meters, which would be somewhere up here. Which means that at this point, at this plane, my object clears the wall. Figure out how much time it takes to get to the wall. Then figure out where it's going to be. It's delta y. Then you can see if it clears the wall.